Alright, I'm going to cover building it and putting on upgraded firmware and the upgraded components in order to print things like nylon carbon fiber, nylon glass fiber, specialty filaments. I'm not going to cover anything that was in the box. This is not an unboxing, so I'm going to get right to it. One of the things that I already did, one of the first things that you can do, this is an all metal extruder. The original one was plastic. It's just a straightforward swapping this out with the all metal one. The reason why that's important is, for me, as much as I'm swapping out filament, the plastic is known to crack over time and degrade. Alright, so let's get into the build. So, let's see these instructions. Step one is to put the risers up, which would be these. The first one that I did, I had to put this whole thing together, with the exception of the build plate and the Y-axis rail. This will be taken completely apart. These little zip ties. This thing sucks. Go ahead and take these off. So one of the upgrades is going to be getting rid of this and using a borosilicate glass plate for the bed. So the all metal extruder was about 20 bucks, and then all the other upgrades that I'll tell you about as I'm upgrading them came out to $99.99. You can buy them all off of Amazon. M5 by 45, and each one of the bags are labeled. So we need the M5 by 45. There it is. All the bolts are metric. All temperatures are in Celsius. So there's two large holes on one of them. It has two large holes. That's for the power supply. Those holes need to be on the inside, on the plate side. Very awkward to get to. So the first one, like I said, the first printer that I did, I had to install this rail and this rail and the other rail at the bottom. And getting this flush was a simple matter of basically you had to put the entire carriage together and then set it level on a table with these bolts slightly loose, everything else tightened down, and then you wiggle it until the feet flatten out, and then tighten down the side bolts. Get those hand tightened for the time being. Alright, and we're going to check and make sure. The other rail has 2 holes side by side near one end. That goes at the bottom. And that's going to be where this mounts to, this piece down here. Getting ahead of myself. Get it kind of started. All right. Careful with the cables in the back. All right. Next step is to install the power supply and the faceplate, the control panel. All right, here's the control panel. That's going to go right here. And that's using M5 by 8, which is these right here. Just tear a corner off. 2 of those out. supply mounts back here. Here's the 2 mount holes here and here. Those are going to line up with the 2 holes here and here. And those are using the M4x20s. Lottie-dottie, here we go. So nice of them to add an extra one of everything. Now we'll start with the top since it's easiest to reach. Snug it just a little, get the other one in. This one's a little tough to screw down. There it goes. That's great. Over here sweating. God, dog. This is a filament dryer for nylon and other hygroscopic filaments. It's basically like a food dehydrator. And for nylon, you got to have it running at 70 degrees Celsius, and it really heats up a room. And I've got 2 of them. There's another one right here next to me. Move that one out of the way. Alright, it's on there nice and stable. Alright, next step is the Z limit switch. And interestingly enough, doesn't say it on there, so it's probably marked on the bag. It's not that one. Actually, it might be that one. M414P. This is the Z limit access switch. Oh, no wonder it didn't mention it. They're already on there. So for all you gun nuts out there, some of these, they have some parts in here, some nuts in here called they're called T-nuts. It's the essentially the same thing that M-LOK uses for their, I mean, these aren't to M-LOK specification exactly, but they are cammed T-nuts. They work extremely well for holding stuff together. So let's move this around. Now the Z limit switch is what gets hit and tells it to stop when it comes down to a certain point. So we're going to go ahead and install that one on there. So that's here. T-nuts. So the T-nuts go on the, it's going to be a little difficult to show you this one. So the T-nuts got to get out of here. The T-nuts go inside this rail here. There's an opening at the top. But the idea is you put it in there. Should work just like the M-LOK system. There we go. Loosen that up. There we go. Only thing I don't like about it is that I can't see. Yeah, see, it wasn't all the way in there. Piece of crap. So the only other way to do it is to loosen these just enough so that it slides down the back sideways. Pain in the ass. But even then, all right. Alright, the bottom one's on. Now that the bottom one is done, just loosen the top one enough until it starts to turn. Kind of help it turn the rest of the way. There we go. Tighten that bad boy down. Alright, Z-limit switch keeps the unit from going down too far. Alright, next thing on here is this deal, which is going to go right here. Using M4 by 18P. So first I want to make sure that this bottom one is on tight enough. Alright, make sure that this top one is loose. Put the rod in there. And tighten it down. Now this one absolutely has to be as tight as you can get it. You don't, this right here is what controls the whole thing, the whole Z movement, the up and down motion of it. If it slips at all, you're going to screw up the print. Alright. And then where's M414, what is this? 18P, 14, 16, god dang. 18P. This one here. And they only gave you 2. M4, that should be this one here. You have to hold it up a little bit to get it started. It doesn't exactly rest on the bottom. Go. These have to be in there really good as well. You want absolutely no movement on that. All right, next part. All right, so we're putting together the top rail. M4 by 16, 2 pieces. M4 by 16. And it looks like they're different. So it's this one here that we gotta use. Two of these. And a washer each. Come on. Alright, got it. So just gonna put this here for the time being. Alright, let me relook at this. So this is where we are installing this. I'm gonna move some crap out of the way. This, and this to this carriage, and then installing the driver cable as well. Let's see. This picture sucks. There it is. Alright. So these two, they're the side with the limit switch. We're going to line up those two holes. You can see that there's kind of a cutout area, so it fits over top of that nut. That's also so you can have access to it. So let's get that right there. Super stupid to get to. There we go. Try not to damage that switch. Alright, so long. So there's a limit switch for everything, so it knows, so the system won't, if you accidentally design something wrong or put a design in that's bigger than your buildable area, these limit switches will keep your system from, like, you'd burn out a motor if there was no stop and it kept trying to go down, you would end up burning out one of these motors. See if we can't add a little more torque to that one. There we go. Alright. That's the end stop for that. Alright. Side goes to here. And that's M4 by 16s. Where they at? M4 by 16. Go ahead and dump all these out. One goes there. Alright, so down started. Cinch it down barely. And the other one. Poke it in there. Alright. Alright, these have locking nuts for a reason. So we're going to torque those down. Alright. Next up, yay! Alright, this is the part I hate, because you're supposed to do this free while it's freestanding and not mount it yet, because down here is where you actually mount it. So up here it's telling you to put together all this stuff. This, alright, which goes onto here. I forgot about that. Alright, first screw up of the night. You got to put that carriage on first, because the bolts behind it, back here, interfere with this, so you can't slide it on. Whatever. Alright, now, that's actually a pretty good tension, and it rolls really well. Now we're going to put the belt and this on. So, the first time I did this, I put the belt on wrong. I accidentally weaved it through something I wasn't supposed to, and I thought they gave me a belt that was too short. I ended up figuring it out before I busted the belt. But go. Alright, so let us take this. I'm going to lightly melt that. There we go. I'm going to lightly mount this down here. I think these are M4s. No, M5. This one is especially irritating because you can't tighten these down all the way because you have to slightly loosen them and then basically wedge it out, because this is the tensioner. This part right here is the actual belt tensioner. So once I get the belt around it, I'm basically going to stick one of the larger Allen wrenches through the side here, and I'm going to wedge it and get it out, and then I'm going to tighten these down as hard as I can to hold it in place. Alright, good enough. Now for the fun part. So, there's a gear in here. Just got to go around that. We have to slip. There's a lip here. There's actually a lip on both sides. Slip this in there. Alright. And then this is the part where I messed up. When I put it through there, I accidentally wrapped it around something else. I don't know how the hell I did that. Come on. Poke it in there. Alright. Both sides are following the groove in the rail. So when I slide this in, it's going to go underneath these wheels. There it is. Alright. Shit. First things first. I want to make sure that it's on track inside and not flipped like it currently is. There we go. Just kind of pull it down to the bottom so you don't have to fish so much of it. And what I do is just roll it over it and pull the rest of it through. Alright, it's tight. Flip it over. Nice and easy. Make sure you stay in the groove. And it's going to be tight, and it has to be tight. Where's the 5 at? Come on. Jeep. And then slip that right through there. There, that's done. Boy, let me tell you. Now I'm going to go ahead and tension this now as it stands. Sadly, you can't really see in there. Yeah, you can. There it goes. Alright. And then I'm going to look the other end, make sure that that one is still on track like it's supposed to be. Hand tighten, just hand tighten. And then take the larger one. Too large. And there's the nut back here on the back. It's a good spot to just wedge it in there. All right. And then just pull on it. Kind of loosen these so you know that you've got all the tension. And then tighten the crap out of these two. Time to time, you may need to recheck. Your tension. This has to be tight. If it starts to get play, you will have X-axis inconsistencies in your print. And you'll be able to tell because for the longest time everything's been printing fine, and then all of a sudden you've noticed that you've got like you'll look at the side of your project that you've printed and you'll see layer inaccuracies. Some will look like they're poked out too far, others will look like they're not poked out far enough. Like nothing's lining up really. Or sections at a time will be lined up, other sections won't be. Alright. That part's done. Step 9. We're gonna place this on there. And it says not to tighten those too tightly. So let's make sure that this is unraveled. All right, and alright, good deal. Well, I'm going to check these top ones. So these, I keep forgetting I can't really see anything. So there's two bolts here and here. It says to tighten them down, but not too tight. Just hand tighten, finger tighten. That might be too high, I don't know. Should be able to. There we go. Let me just check the camera view. Yeah, y'all couldn't really see it. All right. these two bolts here and here. So what I usually do, if they're tightened too much, this rod here is gonna bind up a little bit. So what I do is I loosen them and then I finger tighten them, which I've already done. All right. Next on the agenda is it says to put the spool holder on there, which goes across the top bar. Well, actually, that is the next step, the top bar. So M5 by 25, 4 pieces. M5 by 25. Here we go. 1, 2, 3, 4. This top bar. Alright, so this top bar has these inset holes kind of cut into it. The other side does not. This is the side that needs to face up, otherwise you won't get that bolt through it, the bolt head. M5, is this it? No, hell no, that's not it. There we go. So this part here ensures that everything is square across the two sides, so it doesn't push in or bow out. Let me do this. Okay, Dawn, I didn't see earlier. I haven't been watching. This can print 8.5 inches. The build plate area is 8.5 inches by 8.5 inches by almost 9.5 inches tall. That's the printable area. This printer in and of itself is not very large. It's not very heavy. I mean, as you can see, I mean, you're looking at my fist on the table. It's just up to the back of my arm. I mean, it's not large at all. Let's see. All right, so make sure that all these are tightened down across the top. Done. We're going to put these rubber feet or these end caps. Really for aesthetics, so you're not seeing raw metal poking off the end. That's it for that. Ooh. Power cord down here, other cables here. Go ahead and put the power cord up, that's fine. Alright, so this is really foolproof. This one says X. This one says X. And this one says E. E stands for extruder, which is right here. Plug that in. Turn this to the side. There's a plug inside there. And that is for the limit switch. And then there's a plug right down here, and that is for the actual this motor, which turns this, makes this move. So easy. One's bigger than the other. The little one, it goes in here somehow. Get my fat finger in there. There we go. This one goes right here. There we go. All right, that's it for that. The Z, where's the cable for the Z? There it is. The Z is the short one, still hiding back there. It's extremely short, so you kind of have to bend it, finagle it. But once you get it in, it's not going to come out unless you pull it out. Alright, that's it. The power set up for that. Yeah, I'm not doing the spool holder. I don't run a spool holder. So that apparently is it. Alright, so it shows a picture of the faceplate, the actual control panel right here, because on the back of the control panel there's actually like three plugs, and it says right here EXP3. Don't need that anymore. So you take this ribbon cable, we're going to tuck it around behind, and we're going to look for EXP3, which is the one closest to the inside of the printer. All the way down here on the end. Probably should have plugged that in first before we mounted it. Hindsight, right? Make sure that that's on there properly. There we go. Alright. Now this workbench that I'm on has a built-in power strip all across the front of it. So make sure that your unit is off. Plug it in. Plug it in. See if I can't zoom in. Oh, you can see the front plate. All right. All right, so the Ender 3 logo has a little dragon head and it says Ender, and it's fired up just fine. All right, good deal. Now what we're going to do, onto the upgrades. Clean up the work area real quick. There's a little box somewhere. Here we go. upgrades. Useless, useless. What is this? What is this? Apparently useless. Oh. Oh, that is not useless. This thing goes on there. I need to put some Gorilla Glue on that. Alright, so this little deal here is a programmer. The programmer is required to update the firmware. I've already printed off the mounting kit, and I printed it off in nylon carbon fiber using the other printer. So if you don't have another printer, what I did was I used this just like it is. I printed off this bracket in regular PLA, which is the regular cheap plastic, just so I could have the mounting solution for the upgraded hot end. Alright, and once I got it all together, I then used the printer to print nylon carbon fiber bracket. And then I disassembled it again, installed the nylon carbon fiber bracket, threw away the plastic one. So yes, these printers can print upgrades for themselves. Crap. Crap. Alright. Trash. Zip ties will be used later to tie everything down because we're going to be removing things. Use those. Trash. Yeah, all that can go there. Alright. So first things first, I'm going to set this programmer off to the side for now. Unplug that. Just leave that on the floor. Now here comes the upgrade. So I've got the glass bed. We'll put that on last. It's actually not really glass, so to speak. It's borosilicate, so it's a form of glass. This right here is the type of system, for those who don't know the type of system that this is what's called a Bowden feed system. So the material comes in here, is fed down the tube into the hot end, and is extruded out like that. The other type of system that they have is what's called a direct drive. Direct drive, there is no tube. Filament goes straight into here. It's got its own gear system inside of it that pulls it directly down into it. So there's no, whereas the gear is here and the hot end is here, it's removed all that, which is really, really good for flexible filaments. Yes, you can print rubber with these things. Maybe I shouldn't have said that. So the issue is bend. Right now, the reason why I bought the Capricorn Bowden tubing is because I'm upgrading the hot end. This tube is will actually melt after 240 degrees Celsius. This regular white stuff, and it emits a fume. Whenever it burns, it emits a fume that actually causes cancer. And not just in the state of California. I know how they love to say everything causes cancer and birth defects over there. But this, piece of crap, it's not going to matter. But that causes an issue because it'll melt, one, it'll put off those nasty fumes, two, this crap will melt and get down and clog your extruder. So this stuff is rated for much higher temperature. And as well, it's extremely slick. It has a tighter tolerance, so you can use flexible filament with it, and it matches the tube hole almost exactly. So there won't be any binding in the tube from a flexible filament. But since we're using an all metal hot end, this is one of the upgrades. You don't ever have to worry about this melting. So you can keep that if you don't want to spend the money on this. But this was worth it. I think it was like $9. Let me go ahead and pull the end of that off. So the upgrades that we're installing here, this is called an E3D V6 all metal hot end. And it comes with the appropriate heating element and thermistor. The thermistor monitors the temperature. Obviously, the heater core does the heating. This will reach temperatures of 285 to 300 degrees Celsius. Although you shouldn't run this one. You need to get a ceramic one, buy a ceramic upgrade. But the one that comes with the all metal hot end will take you up to 285. You shouldn't run it at 285 because the system, this is a 12 volt system. It'll have problems keeping up with the power output, trying to maintain that temperature. So what the software does, and we're going to put that upgrade on here soon, is maintains that you can only go 15 degrees Celsius below max temperature. So what I did in the software, I already modified the software so you guys don't have to watch that boring crap. But I've set it at 300. That way I can set it for 285. It doesn't need to be at 285 long in order to set the other upgrade, which is, you can't see it really, but it's a hardened steel nozzle for abrasive materials like carbon fiber, Kevlar, glass fiber, anything other than just straight nylon. Nylon itself is soft, is not, and if all you're doing is printing regular nylon or non-abrasive materials, you don't need a hardened steel nozzle. Hardened steel nozzles are about $15 each. But for what I'm doing, I need all those. I need all these upgrades. So yeah, so a stock Ender 3 runs you $229.99 on Amazon, plus tax. If you have Prime, shipping is free. And then 120, about $140 worth of upgrades. So you're looking at about 380, just below $400. You can have a completely upgraded system. We're not going to use any of the fans. I'm not going to use any of these fans, so I'll be disconnecting those. There is one fan I'm going to use that comes with it. It mounts directly to it. But that's to cool this part, not the actual part. There's a part cooling fan, which is here, and it blows air across the bottom onto the part that it's printing. When you're printing with these, especially materials that require high temperatures, you have to turn that off. And I don't even worry about turning it off because I don't even install one. It's not needed. If you do your slicing properly, you won't need it. That's the other thing, slicing software. There's Cura. Cura is free. I didn't particularly like it. A lot of people use it, and that's fine. I use Simplify 3D. It costs $150. I love it. It boasts faster printing times because of the algorithms that they put in to determine start and stop printing spots. Let's see. All right, there we go. So that's off. All right, and then I don't know if you can see it or not. There's two little nubs there. That's where we're going to install our first upgrade. Right here. That like that. I think I'm supposed to use these. I can't remember. No. Small ones. We'll use the longer ones up top. Alright. Piece of crap. Nylon carbon fiber has a very, very high tensile strength. Trying to break this by hand, you got to be strong. I can't do it. I can't break this by hand. It requires too much force, too many pounds per square inch. I think like 700 or 800 or so. It's pretty ridiculous. Somebody online posted a video of how they printed the transfer gear in the gearbox of a rear-wheel drive pickup truck in nylon carbon fiber, and he was able to drive it off his property before it chewed all the teeth of it off. But it worked. All right. So, take that off. Oh man, that's tiny. Not that tiny. Come on. Alright, I'm going to have to do this the old-fashioned way. Alright, so easiest way to get this out is follow the double white and double red line down into this box down here. What did this just do? Oh, nothing. I never plugged that in. That would have sucked. That's the Z-stop, the important limit switch that I was telling you guys about. Is that one it? Yes. Come on. Dang.
Almost like they don't want you to get in it. There we go. Get the hell out of here. This is my new stuff. Out the way. Go. All right. All right, be careful when removing the plate. There's a fan on it that's already attached. So now what we're going to do is well, crap. How many white lines do we got going on there? 2 from there. Yep, that's, wait a minute. There it is, that's the one on the very end. Wait a minute. Is that? Oh, you gotta be kidding me. They've glued it. They used hot glue and they glued that crap in there. Which is a great idea because you don't want it being pulled out by accident. At the same time, it sucks because I'm trying to pull it out. Take this out. There we go. Alright, there's that, there's that. Making these changes, do them one at a time so you don't forget what's what. It's not a big deal because all you have to do is go online and look up what's supposed to plug into what. Come on. Baby. There we go. There we go. Take it easy. Don't bust the board. Clear away that excess. Now, I'm going to take this. Pull it out. Come on. Just trying to one at a time, man. All right, there's that. Oh, all right. There's more zip ties, cinching everything down. You know, that's why it was so difficult to pull that out. How about now? Oh, piece of crap. Some tape, nylon tape. If you're doing what I'm doing, make sure you don't cut something important. There we go. All right. Come on. Such a pain in the butt. I really don't want to cut it. I really don't want to cut it. Stupid tape on there. It's a terrible idea. What I'm doing is a terrible idea. I know. Still terrible, but not bad. Just make sure you don't snip some wires. They didn't have this on the last one. I don't know why. They keep adding crap. All right. Once more we're feeling it. Now just remember we gotta freaking send it back down. There we go. Come on.
Get out. Oh, God. Ah. Oh my God, I hate this crap. Why in the hell did they tape it? That unplugged, by the way. I didn't just rip it out. I'm trying to grab all these cables and stuff them inward so I can see what tape is left. There we go, come on. Wow. All right. That's gotta be it. That's gotta be all of it. If it's not, I'm gonna be ticked. There it goes. Jesus. All right. That goes in the box with the other one. Two fans, blue and yellow, black and red, tiny lines. Here's the blue and yellow. That's the park cooling fan. We will not be replacing that one. I'll take my handy dandy screwdriver and scrape off this hot glue that they use to hold everything in place. Wow. And that like legit just pulled off the entire thing from the board. A biggie. I will clean off this glue and then there we go. And then replace that. This should know. That was the back side, that was the front. So that means that went on like, you know. Wow. There we go. All right. So that's the blue and the yellow, and then the black and the red is actually just the bare wire, and that's actually the cooling fan for the, where'd it go now? That's the cooling fan for the, for this piece here. So we will loosen those. 1, 2, There we go. Both of those are loose. Alright, there we go. Now, now comes the fun part. This should be the last and easiest of it. Alright. Make sure that this doesn't get tangled. There we go. Alright. So that's the part cooling fan. Just right here. There we go. Alright. We're not going to use this. We're going to use the hardened steel nozzle. I'm going to pull that out now. And for nozzles, I use 0.4 millimeter, and that's about as far as I go. I don't use the bigger ones or the smaller ones. Put the black clip into the top. Don't freaking destroy it like I almost just did. There we go. That's going to be what holds the tube into place so it doesn't just pop out. And then here's the heater block. We're going to use I can't remember which way this is supposed to go. I think that's supposed to go. No, that's not. Okay. Alright, so the short end goes into your actual heater block. Alright, you don't want it to go in too far. You're going to screw this in. You're going to screw your nozzle in. Alright. Here's the trick. If you can screw your nozzle all the way down, you went too far. So, or you don't have your brake in long enough. So what I did was I unscrewed it until I could just barely see, I can see a crack, basically where it's not all the way flush. And then I take this and I screw that down a little tighter, just hand tight for right now. Alright, and then this is where you need the compound that comes with it. Alright. And it's just a white goo. It's a heat sink, same type of stuff that basically goes between your processor and the heat sink on a PC, for those of you who know about that. Not exactly, but pretty close. Alright. And we want to make sure you don't get it inside the tube. Rest of that's trash. I'll wipe off that excess piece of cardboard. Alright, and then we're going to screw that on. All the way down until it stops. We're going to call that good. Alright. Next up, where is these over here. Alright, so this right here is basically an extension cable for your thermistor. Let's go off to the side. So here's the thermistor. It's a little one, and then so just know that the elbow, that part pokes out, right? That goes in there. There's 2 set screws that hold that in. We need to locate those. Didn't seem to see them in any of the bagging that the stuff came in. Here it is. There they are. So the reason why I haven't updated the firmware yet is because I don't have these new parts on. These new parts, actually, you have to change certain aspects of the code to reflect the new heater cartridge and thermistor. Namely just the thermistor. The heater cartridge is just your temperature, your max temperature setting, and the thermistor requires an actual, for you to set the actual code for it. Certain thermistors require more, well, I'm sorry, certain heaters require more or less voltage for it to do its job. Whenever you screw this in, don't screw it too terribly tight. Otherwise you will damage that cartridge. Same with the heater cartridge. You don't want to crack it. You got to remember that there's not too much force being applied as this thing's moving around and doing its business. It's just kind of sliding around. So you want to put both of these in on the same side. Okay. The heater cartridge. So the thermistor, you want it to not quite be flush with the other side, but close. The heater cartridge, you want it as centered as possible, so the heat's going all over that. All right. Over here. Alright, get that in there. didn't seem to be it. That isn't it. That is a replacement set screw for the other one in case if you lose it. And you got to use this big black one because it doesn't actually touch the heater cartridge. It's going to clamp down on the metal. Alright. Just enough. Finger tight, maybe a tad more than finger tight. See, that wasn't enough. Alright. That should be enough. Alright. Now, just to get this so it sits in one spot, we're going to go ahead and mount that right there. Alright. There we go. Make sure you've got it the right way. Where are my screws? There they are. Crap. Set that down for a second. Not right. Ah. There it is. That one's it. Alright, so forget about this one. There's gotta put sockets in the back. So, or not sockets, freaking nuts. Requires a couple nuts to go in the back. And these aren't long enough. So, sadly, now that sucks. That sucks. So these are supposed to use all the bolts that come with your Ender 3. You shouldn't need anything else. Unless, of course, that's not those. It's not those. I use some long silver ones. The other one. I think that might be it for that. I'm gonna have to buy some nuts for that so I can mount it. Oh my god. So we will feed this through the hose. Yeah, I can't complete this build without those two bolts and nuts. What's going to happen is in order to set this correctly, I get all this plugged up and get it mounted, and then I have to heat this up to 280 degrees Celsius, and then I hold the heater block, not with my hands obviously, and I torque this nozzle so it seats. If you don't do that properly, like I didn't do the first time on my first printer, I had nylon carbon fiber squeezing out of every orifice on this thing. It was a nightmare to clean up. An absolute nightmare. Anyway, oh God, I've been at this too long. All right. Go ahead and take this off. All right. That's pretty much it for the parts. Like I said, you're going to have about $180 of upgraded components, upgrade components that you add to this to do specialty filaments. Specialty filaments like nylon carbon fiber, nylon glass fiber, those are about anywhere from like $60 to $90 per 500 grams. They do the weight of the roll in grams. Regular plastic like PLA, which stands for polylactic acid, that's extremely cheap. You can get a 1 kilogram roll for $20, and they come in every color under the sun. Why is this? Come in every color under the sun. Nylon carbon fiber only comes in black. Nylon glass fiber comes in about 7 or 8 different colors currently. So yeah, so you can already see. So nylon, let's say nylon carbon fiber, you're paying $128 for a kilogram. Whereas PLA, you're paying $20 for a kilogram. Peak is a very extremely high-end specialty filament that it requires 430 or 40 some degrees Celsius in order to print it. 500 degrees Celsius is just over 1,000 degrees Fahrenheit, to give you an idea. I'm printing nylon carbon fiber and nylon glass fiber at 258 degrees Celsius. That's why you need those upgraded components. If you don't have an all-metal hot end, it's not going to withstand the heat. You're going to completely destroy your hot end, and you're going to end up having to replace everything anyway. 3D printers, I can make anything. So the question you got to ask yourself if you're wanting to get into like specialty printing with the really cool filaments is, do you need tensile strength? Does it taking weight? Does it need to be able to withstand someone hanging on it, someone pulling on it, something sitting on it, or being squished between two things? Or in the case of, I do gun parts, specifically AR-15 gun components. So yes, I've printed an AR-15 lower receiver using nylon glass fiber, and it hasn't broken yet. We've got over 200 rounds put through it. We're still working. We're going to get to 1,000. We're going to try and get to 1,000, see if it breaks. We don't think it is. So there you have it. Nylon glass fiber is for impact, extremely high impact resistance. There's also nylon Kevlar. No, you're not printing bulletproof armor with nylon Kevlar. Nylon Kevlar is whenever you're trying to make gears or components that are rubbing together and creating a lot of friction. That will withstand that. There are, I'm sorry. Let me a second. I'm seeing some weird stuff here. All right. So that's that. End user usability, anything you can think of. Like game pieces. I've made checkers. I've made a chess set. Hey, Kathy. I've done. Speaking of Kathy's husband, Mark. I'm in the process of printing for his. Hopefully, I'll have it done for his birthday. The Oakley's. The company Oakley has a sunglasses stand that that somebody redesigned, so it's printed in 3 parts, and I'm printing that for them. So there's some end user usability there. 3D printer components, like I said, the bracket that I printed for the upgraded hot end. What 3D printing can't really do is you can print metal. They have a metal compound, but you're still not just printing metal. You're printing what's called a green part, what the metal industry calls a green part. You have to send that off to be finished. So they basically bathe it in this chemical for like 18 hours or more to remove the powder. Well, it's not really powder coating. It's some kind of coating component that they've put into the filament. And then, hey Mark, and then they basically do it's like a kiln for metal. What a kiln is for pottery, they have the same thing for metal. So after they bathe it in that chemical, they stick it in that kiln to fire it and finish the product. And then they send it back to you. So we're still not 3D printing metal yet. There are filaments that have like metal shavings in them, but very, very like dust particulate type metals, and they're soft metals at that, like copper and bronze, things that can get melted down. But what was that one? Tungsten. There's a tungsten type filament as well. So basically metal's not being printed. There is a filament out there that is extremely expensive. It costs like $400 for 500 grams, that's insanely expensive. But it's for like printing circuit boards. The lines, the conductivity lines. So that actually adds a very interesting aspect to 3D printing in and of itself. If you have a multi-extruder, what's called a multi-extruder, you have 2 print heads, and you can print, essentially you print 2 different colors at the same time. So on mine, as you can see, I've only got one head. You can see it there with the red thing. So with multi-head printing, so I can print, let's say Mickey Mouse, right? Make the ears black and the face red, whatever. Okay. So with this, you would use, like, let's say nylon carbon fiber, or just regular nylon, and you would print a surface, and then you could basically print your own circuit board. So you would print it with all the holes, and then go back over it with the conductive filament and draw the lines, so to speak. Anyway, it's pretty cool stuff. The nylon carbon fiber is extremely lightweight. So is the glass fiber. The glass fiber should be extremely interesting to print for RC vehicles and aircraft, quadcopters. The nylon carbon fiber would be extremely useful with the propeller blades. I've done phone cases. You can do eating utensils, things that you can use in the kitchen if you intend on selling such items. They make a particular filament that's FDA approved, but you have to use that. You have to use that particular, and then of course there's other like fluid handling crap that you got to know and deal with. So that's it. I'm gonna have to come back and finish this video because I don't have those 2 bolts. I thought that was the kit that used whatever you had, but apparently not. Apparently I need 2 36mm long bolts with the nuts that go with them. So I'm gonna have to come back and finish this video for that. That portion will just be very boring. Let me flip back around. So what we're looking at is the glass plate, which just gets put on here, and I use 2 clips. I put 1 clip here, which is out of the way, and then again 1 clip back here to hold it in place. We'll then tighten down all of these and do the bed leveling, which we have to do by hand. Of course, as soon as I get the bolts for that mounting bracket, I can put all that crap together. But there you have it. It's very cheap. Like I said, $230. You can make whatever you want. These dryers are $140 each. They can do 2 spools at a time. You can actually multi-stack them. I keep extra filament spools over there. Comes with 1 of those each. You can put the disconnect packs in it, and it's got a hand pump, which is really nice. It sucks all the air out of it, and the top of it sinks down. I've made barrel flags, foregrips, pistol grips, lower receivers, adjustable stocks. That's on that end. Anyway, I will keep you guys posted for the next video. I'll try and get that done. I'll try and get that done tomorrow. It's just 2 bolts. So, all right. I look forward to finishing this. There's not a whole lot out there that shows you from start to finish. 1, putting these things together, and 2, upgrading them. I had to look everywhere for the upgrades and the process in which to do it. So, all right. I'll talk to you guys later.